A simple spoon can unleash a violent explosion when submerged in boiling water, defying basic physics. This seemingly innocent utensil holds a secret power, ready to surprise even the most seasoned cooks. We often overlook its humble design, but the spoon is a key player in food science. Understanding the chemistry behind cooking transforms everyday meals into culinary marvels. It's not just about taste. It's about intricate molecular interactions happening right on your plate. This exploration reveals the hidden science within your kitchen tools. Prepare to see your cooking and your spoon in a completely new light. The magic begins with superheated water, a common element in many cooking processes. When water reaches temperatures above its normal boiling point, it becomes unstable. This phenomenon, known as superheating, occurs when water is heated in a very clean container. There are no dissolved minerals or imperfections for bubbles to form upon. Imagine water molecules holding immense energy, waiting for a trigger to release it. This superheated state is like a coiled spring, incredibly volatile and ready to snap. But that's not the strangest part. The spoon is about to change everything. Introducing a foreign object, like a spoon, into superheated water provides that trigger. The spoon's surface, even if seemingly smooth, has microscopic imperfections. These imperfections act as nucleation sites, perfect spots for rapid bubble formation. As the spoon enters, it disrupts the water's delicate balance, forcing a sudden phase change. The stored thermal energy is released almost instantaneously, creating a powerful steam explosion. It's like dropping a tiny pebble into a perfectly still pond and causing a tidal wave. The rapid expansion of steam can forcefully eject the water and the spoon itself. This dramatic event showcases the immense energy contained within seemingly normal water. The same principles apply to volcanic eruptions and even industrial processes. This phenomenon highlights the importance of caution when heating liquids. Always stir gently or add ingredients slowly to avoid unexpected boiling over. The spoon, therefore, isn't just for stirring. It's a catalyst for demonstrating physics. Its metallic structure and smooth finish make it an ideal nucleation trigger. This dramatic display of thermodynamics is a chef's secret weapon and potential hazard. It reminds us that even familiar objects can reveal astonishing scientific principles. Understanding this helps prevent accidents and enhances cooking safety. The way heat transfers and energy is released is fundamental to all cooking. Consider the humble potato. Its cooking involves complex starch gelatinization. When heated, starch granules absorb water and swell dramatically. This process softens the potato, making it palatable and digestible. The water molecules are literally rearranging the potato's internal structure. Fat molecules in butter also undergo changes, breaking down into smaller compounds. These smaller compounds create rich, complex flavors that coat your tongue. Proteins in meat denature and coagulate, changing their texture and color. This is why meat becomes firm and changes from pink to brown when cooked. Enzymes in fruits and vegetables can also be activated or deactivated by heat. This affects their texture, color, and even the nutritional content. The Maillard reaction, responsible for browning and savory flavors, needs specific conditions. It requires amino acids and reducing sugars heated above a certain temperature. This complex series of reactions creates hundreds of different flavor compounds. Even the simple act of whisking eggs involves introducing air into the mixture. The proteins in the eggs trap these air bubbles, creating foam. Heating the egg foam then denatures these proteins further, stabilizing the structure. This is how meringues and fluffy omelets achieve their airy texture. The interaction between ingredients and heat is a delicate dance of molecules. Each element plays a crucial role in the final outcome of your dish. The spoon, in its various forms, facilitates these interactions perfectly. It allows for precise measurement, even mixing, and controlled heat distribution. From delicate sauces to robust stews, the spoon is indispensable. It's a tool that bridges the gap between raw ingredients and delicious food. The science of cooking is a journey of discovery with every meal prepared. Embracing this knowledge elevates your culinary creations to new heights. So next time you stir your soup, remember the hidden science at play. If you found this culinary chemistry fascinating, please subscribe for more incredible insights. Don't forget to like this video and share your favorite cooking science discoveries in the comments below. Exploring the science behind our food makes every bite more meaningful. If you found this culinary chemistry fascinating, please subscribe for more incredible insights. Don't forget to like this video and share your favorite cooking science discoveries in the comments below.